Set of notes for the chapter. We're still talking about least square regression lines. So today you're just going to learn where the least square part of that comes from, but these are still trend lines, lines of best fit. When you have a scatter plot, if you see that there's a linear relationship, the least squares regression line is the line that goes through most of the points. I'm just going to show you the big overall theme is I'm going to show you how to come up with the least squares regression line in the calculator. Say something like this, because that's not anything that you would just be able to do by hand. So let's just review really quickly. You just took a quiz. Most of the grades look fantastic. Some of you struggled just a little bit. Let's kind of find out where that is. The equation of the regression line for predicting y, the number of steps required to walk the length of a school hallway, and x represents the height of a student, is here. So again, x is how tall a student is, and y is the predicted number of steps that they required to walk the length of a hallway. So it says on A, one student who is 67 inches tall, so that's an x value, took 46 steps to walk the length of the hallway. That's a y value. And so if it helps you to kind of label some things, the 67, that's the height. 46 steps is the actual y value, so I'm just going to put y. Calculate the residual. Well, for residual, you need to think, okay, AP, that's how I kind of helped you remember, which is actual y value minus predicted y value, or y hat. So we have the actual number of steps that this student needed to walk the hallway, so 46, minus, now what I need to do is just figure out the predicted value, or y hat. So I'm going to say, all right, based on the fact that they're 67 inches tall, I'm going to go off to the side, and I'm going to use that line regression formula, 113.6 minus 0.921, and then I'm going to plug in the height of the student to see what I would predict their number of steps would be. 113.6 minus 0.921 times 67. So y hat, the predicted number of steps, is like 51.893. So I'll just come back over here and plug that into my residual formula. 46 minus 51.893. And you can round at the very end if you want to, negative 5.89. And I wish I had asked this in the notes, but just to kind of recall, would this point on the scatter plot, would this particular point for this student be above or below the line?
Below.
How do you know it's below the line without seeing the graph? Good. Because if the residual is negative, that automatically means that data point on the scatter plot is somewhere below the regression line that's drawn through there. What's it called if we plug in like a ridiculously large or ridiculously small x value? Extrapolation. Like I could plug in a person who's 1,000 inches tall. That doesn't even really make sense. I could plug in anything I wanted. But if it's really far away from the x values used to get the line, it's called extrapolation. Gentlemen, stop your side conversations. What does the slope represent in context? This is a little bit more challenging. But if you think, okay, for every one that x goes up, y is predicted to blank, then you can usually kind of guide yourself in a multiple choice setting. So here, since x represents the height of a student in inches, that means for every increase of 1 inch in height, as x goes up by 1, that's always how your slope starts, your slope phrase. The predicted and then figure out what your y is in context, and that's the number of steps. So I'm just going to say the predicted number of steps. And then if your slope is positive, you're going to put increases. If your slope is negative, you're going to put decreases. So I'm going to glance back up there really quickly. The slope is the number in front of x, and it's negative. So for every increase of 1 inch in height, the predicted number of steps decreases by about 0.921. Which makes sense. I mean, I guess here the relationship is the taller you are, probably the longer your legs are, maybe, and so it takes you less steps to travel the same route as a shorter person. Some of you, this question on the quiz kind of got you a little bit, but does the y-intercept have meaning? Sometimes the y-intercept, when you put it into real-world context, doesn't have any meaning. Like if you get, I think on the quiz it was like negative chirps per second. But y-intercept always means when x is 0. So in this case, if x is 0, that means a student who's 0 inches tall. The y-intercept would mean that a student who is 0 inches tall is predicted to take 113.6 steps. Then I'm going to answer the question, does that have meaning in context? No, that's silly. Nobody's 0 inches tall. So this does not have meaning in context. Guys, if you can wrap your mind around that, you should be proud of yourselves, because that's an AP statistics level question right there. This type of question is on the AP stats exam. So being able to spot the slope and spot the y-intercept and then just give meaning to it. Regression lines can help us make predictions, so it's important that we use a good regression line. In other words, we're not just going to rely on our eyeballs and our hands to just draw a line through the data. By definition, good means that it'd be a regression line that makes the residuals as small as possible. For this reason, statisticians prefer using the least squares regression line. LSRL is how we abbreviate it in AP Stats. Here's what that means. The least squares part means your calculator is going to come up with a line that makes the sum of the squared residuals as small as possible. I know that's a lot of words. I'm going to illustrate it the best that I can. And even if you really can't figure out this, it's okay as long as you can use your calculator to come up with the equation. That's the task that we need today. So you're going to learn how to get that from your calculator. I just want you to glance at this graph from our notes last time. This is how many miles a truck has been driven, plotted against the price that it's listed on the internet. It's listed out on the internet. And so remember each of these data points, the reason there's a little line drawn there is those are all the residuals. A residual is how far away a data point is from the regression line. What we want to do is we want to make, when I add all of those residuals up, we want to make that sum as small as possible when those residuals are squared. It'd be nice if we could add all the residuals together and get 0, because that would mean that every single point is smack dab on the line. Think about that for just a second. If all of the residuals are 0, then every point is on the line. That would be a perfectly linear relationship. So when you turn the page, you'll hopefully be able to see in the illustration where the squares comes from in the least squares regression title of that line. If I take each of those residuals from the truck problem and I square them, and here's a really good illustration of every single residual, we just draw a square from it. Okay, that's where all these little squares are coming from. we want to make the sum of the areas of all of those squares as small as possible. So just look what I have in bold. Of all the lines that you could draw through the data points, like how does your calculator know this is exactly where to draw the line? Because it's calculating the one that makes the sum of all of those squares the least. Least squares regression. Again, that's not really like the most important thing for you to learn today, but it's nice to know where that phrase comes from. What I really want to show you is how to take some data, put it in your calculator, and come up with the least squares regression formula so that you can do that on the test, because then you'll need to be plugging into that to answer some questions. I think the easiest way for me to show you, so it's all written in your notes, is to just jump in there and show you how to do this. So here's what I want you to do. Go to example 1 on page 3. I'm only going to do this once. You only have one time to learn this. That's it. Because it's not difficult, but if you're spacing out or you're on your phone, you're not going to have a clue how to do it. So please tune in. I'm only going to do this once with you. Here in front of us, we have a table of values. We have a bunch of foot lengths, and we have a bunch of heights. And instead of this table just being one long table, they did a side by side. So just stare at that and make sure you understand. There are 6 different people represented. There are 6 people who we recorded their foot length, and there are those 6 people we recorded their height. So just understand that. Use technology to calculate the equation of the least squares regression line. So we're going to do that, and then we'll just answer a couple of quick questions about it. All right, here's what I want everybody to do. Hit the home button. Under documents, hit new. We want to open a new document. Don't save the old one. But what I want you to open is a list and spreadsheet. That's option 4. So home, 1, no, 4. And your calculator should look like this. It's almost like an Excel document. What you need to do is arrow up a couple of times until you get to the box that says A, and I want you to title that column. You can title it foot length. You can title it centimeters. You can title it X. And hit enter. Whatever you want to title it, and on the paper, that's foot length or centimeters, or just it's your X value. Then I want you to arrow over to the box that says V, and I want you to give that column a title. You can type in height. Probably don't want to type in centimeters if you already did that for the X column, because they need to be different. So I would type in H or height or just Y. It's a good habit to give each column a title. Now I just want you to enter in the data very carefully, because if you mess up, then your regression formula won't be correct, and then you can't answer anything correctly. So let's enter in all the foot lengths. 23, 32, 22, 28, 28, 23. The process is easy. It's just something you haven't done before, so I'm going slow. And then type in the heights of those people. So arrow all the way back up, because you want to match up the foot length with the height. And the more you use these calculators, the more familiar you'll be with them. I know for some of you, this is the very first year you've ever even picked one up with Inspires. And they can be intimidating. So enter the data. Does anybody need me to go over how to do that again? You're all very smart. You're having an old person explain technology to you. Okay, now, what you're going to do next, it doesn't really matter what box you're in. Let's say you just ended it. Okay, I want you to hit menu, statistics, stat calculations, And then I want you to look at this menu here. What we're doing is we need a linear regression, but wait a minute, there's two options right there that say linear regression. I know that you're used to mx plus b in all of your algebra courses, but the way that we learned it in statistics is that option 4 that says linear regression a plus bx. I want you to select that. So I'm going to back out of this, and I'm going to do all of that over again in case I lost any of you. Menu, statistics, stat calculations, option 4. And then this menu pops up. All you need to tell your calculator is whatever you titled your X column. I just used X, so use that little drop-down menu. You can use your mouse and click on it. You can actually just arrow over to the right and it'll drop down. But choose your X column title. And then go down where it says Y list and tell your calculator what you titled your Y column. It might just take a second for you to kind of figure out what buttons to press, and that's okay. Because once you figured it out, you're going to be golden. That's all you need to change on this menu. We're about to have the answer on our screen. So pick your X list, your Y list, and then just go to OK. Now I can't see all of the information on my screen, so some of you might have to arrow up like I do. You're just going to have to arrow back up to the top of your spreadsheet and look what the calculator gives you. It tells you A, the y-intercept, is 82. It tells you B, the slope, is 3.31-ish. If you typed everything in correctly, this is what you should have. Does anybody need me to go through that explanation? Okay, so here's what I want you to do. Go to your notes. The y-intercept, A, according to the calculator, is 82. The slope, B, is we're going to round 3.31, and it's positive. So put those together and you can write the y-hat equation. The least squares regression line is y equals A plus B x. Now you can use that to plug into to answer any questions, that style of questions that you've seen before. I also want to point out that in this chapter we talked about correlation. We talked about R, how strong the relationship is or how weak it is. Your calculator has that for you right there as well. Don't look at R squared. That's something completely different. Look at just plain old R, 0.84. Based on that, you guys, would you say that there's a strong or weak relationship between the X and Y variables? Pretty strong. Why? Yes, because it's really close to 1. R is always going to be between -1 and 1. So that's pretty strong. And then we're just going to use that to answer these questions. Predict the height of a senior with a foot length of 30 centimeters. That would not be extrapolation because, look, 30 is definitely a reasonable foot length. We've got foot lengths ranging from 23 all the way up to 32. So just plug into your regression line and let's predict. So 82 plus 3.31 times 30. And a quick way to just get back to a calculation screen is to hit this little scratch pad button right here. So you don't have to like open up a new document or anything crazy. Just hit that scratch pad button in the back in the calculator mode. 82 plus 3.31 times 30. So I would predict that this student's height would be 181.3. Everything is in centimeters. So there's the answer to that. I predict the height of a student with foot length of 30 to have this height. But turns out that the height of that person is 187. So this is the actual height. That's the actual Y value. What's the residual? Is it above or below the line? So this ties everything together and then we're done for the whole chapter. So for residual, you need actual minus predicted. We just calculated the predicted up here. So actual it gives me is that student is actually 187 centimeters tall. I predicted that they were 181.3 centimeters tall. So the residual is 5.7. Would that data point be above or below the prediction line in the scatter plot? Above, yeah. And I just want to show you something really cool. You do not have to know how to do this, but I want to show you. Okay, you can just look up here. Your calculator can actually make a scatter plot. You don't have to know how to do this, but it's kind of cool to watch. If you open a little statistics document and you title your X and Y axis, here's the actual scatter plot of those 6 students. And then from here, you could have your calculator run a regression, and it'll actually put that line of best fit on there, which is really neat. And you can see it's the same as what you wrote on your paper. It's that 82 plus 3.31. It just kind of gives you a visual of the actual scatter plot. Okay? So that's it. That's all I got. We are done.